In college algebra, we wrapped up our complex number set of notes. We ended right here the other day, so that's where we picked up. We started with this idea called complex conjugates, and it's this clever way to get rid of an I term. So if I have something like this, or if I have something like this, if I multiply by the other one right next to it, the i's cancel out. It's pretty nice. So imagine for a minute A and B are numbers, and you have the letter I attached to a B. There's a clever way to get rid of the I, because down here, to simplify, I cannot be in the denominator, which sounds funny when you say it out loud. All right, so whoever thought this up, it's a very clever way of getting rid of I. So let's practice. If I FOIL this thing out, I get a squared, I get negative ABI, positive ABI, and lastly, negative B squared I squared. So take your time, look at it. The middle two cancel out. And that last term turns into a positive B squared. Because of the I squared. So we end up with A squared plus B squared. It's a really nice way to handle I in the denominator, because you can get rid of it. So let's do that. One thing you got to be careful of, though, when you multiply by the complex conjugate. Now let's back up. I'm just going to erase my arrow because I just don't want that in the way. Because I can't just simply multiply by that. That would be making up a number, like pulling a number out of thin air. I have to multiply kind of like a common denominator, top and bottom, by that thing. Because if I do that, that's like multiplying by 1, because that divided by that is 1. It does create a messy second step, though. Because I'm going to get 4 terms, top and bottom. So FOIL that out. If I draw too many arcs, it gets messy. So I'll draw the arcs on the top. We get 14, 35i, 8i, and 20i squared. Let's do the denominator. We get 4 plus 10i minus 10i, and lastly, negative 25i squared. So easy to mess up on these problems because there's negatives going all over the place. These two cancel out. This one right here turns into a negative, and this one is a negative, but the front's negative, so it turns into a positive 25. So we can do a lot of simplifying here. I can do 14 plus 43i minus 20, because that I squared turned into a negative 1. Should I write that? And then in the denominator, I'm left with 4 plus 25. And let's take it one step further. I can combine the 14 and the negative 20. And I get 29 in the denominator. So kind of ugly process, but you do end up with a nicer looking fraction than we started with. All right, let's try some other weird expressions that have negatives in them. For these, I would say if you're comfortable with square root of -1 being I, then this is just a review. Because we're going to turn square root of -18 into 9 times 2 times -1, and we're going to turn -8 into 4 times 2 times -1. So that 9 comes out, and so does the -1. And the 4 comes out, and so does the -1. So we end up with 3i square root of 2 minus 2i square root of 2. And I would say that those are two like terms, because this, it works just like a variable. I have 3i square root of 2's minus 2i square root of 2's. So I am left with 1i square root of 2. That looks kind of weird though, so maybe you'd rather write it like this. I like that way better. All right, let's try another one. This one, they're all kind of weird, but this one especially, I think. So I see the squared, so I like to write it twice. That way I don't miss any terms, because I should end up getting 4 terms, kind of like you saw in the problem on example 4. So I FOIL this thing out. And I end up with a +1, a negative square root of -5. This gets really tricky with the negatives. Another negative square root of -5. And this last one is really weird. Plus square root of -5, -5. I want to be really careful with how I write that, because in this case, 2 negatives don't make a positive. So let's simplify a little bit. Now, the result right there on the far right is just, let's back up, is just a -5. And if that bothers you, think of it as, since I have a negative under the radical, the rules kind of change. Because under the radical, a negative just doesn't belong there. So my rules of a negative times a negative, they don't necessarily apply because we have an imaginary number. It's like you're in a whole other area of math. So when I do that, this really is I square root of 5 times I square root of 5, which then becomes I squared 5, which is -5, because I squared is -5. I hope that makes sense. It's a weird idea. I can take this one step further. I got this negative right here I got to deal with, so I have 1 minus 2i square root of 5 minus 5, and 1 minus 5 is -4. So finally done. That one's a tough one. All right, last one. This one is not as tough. At first glance, it doesn't look like there's math to be done, but I can simplify this, right? I can break that down to a 25, 2, and -1, which becomes 5i square root of 2. And then I have all these multiples of 5 that I can divide by 5. So we have this right now. And then let's divide everything by 5. 5 goes into 25 5 times. 5 goes into 5 once. 5 goes into 15 3 times. So our final answer would be -5 plus I square root of 2 over 3. All right, hopefully that made sense. See y'all later.